Thanks, Berko, for the introduction. So this is Niek, I'm Jean-Paul, and we're here to talk about GraphQL and what we've learned from using it in production. We are both from Target Holding. This is actually a picture, I think it's 1.5, maybe 2 years old. Since then, our team has grown a little bit, and usually we sit at desks. But this makes for a nicer picture. Yeah, so at Target Holding, what we do is we build stuff with data. So we love data, and I think Thomas is not here because he wears one of our T-shirts. It says, "I am data, who are you?" Look him up if you see him later. So we build stuff with data, and we store data, but we love to add value to the data as well. And so what that means is that we do things like machine learning. We do quite a bit of machine learning, but that also means that we need to build platforms and apps and stuff like that to get data into our platforms. And so that is what we do at Target Holding. Niek is one of our backend engineers, and I am part of the AI machine learning team. But I also worked with the app that we're going to show later. And stuff like that. So what is GraphQL? So GraphQL is a different way than REST to create an API. GraphQL is very interesting because you can use it to describe your data, to request specific fields from all of the objects that are present in your data model. And because it's typed, the results are more predictable than when you're using REST. Usually. It was developed by Facebook in the beginning. They used it to connect their front-end stuff to the back-end. And I read that it's now part of the Linux Foundation, so there's also quite a bit of community around it. The thing that we love about GraphQL as well is that it's designed to have documentation built in. So all of the tools that we show, they have a documentation browser, so you can view all the types and the things that you can request of all your endpoints. Last PyGrunn, there was a presentation by Oscar on GraphQL, the basics of GraphQL. We'll talk a little bit about the basics as well, and then move on to the stuff that we learned. But Oscar neatly summarized some of the downsides of REST. And basically, that is usually you fetch either too little or too much data. You have a lot of calls. If you get too little data, then you have to have many calls to get all the data that you need. Documentation can be a problem. It's hard to discover what you can actually request from a REST endpoint. Smart generic clients are lacking. This is very interesting because if you're building an app or you're developing things that you want to do, it's useful to have a client that can tell you, okay, you can request this field from this data object. You have a lot of post-processing in the end. If you have all these calls and then you need to combine all that data to show something in your app, then you need to have all that post-processing. So you have much to decide, and there's a mismatch between reality and API. The talk is on YouTube, so if you like, you can also look that back. But just follow along because everything will be clear. So why did we decide to use GraphQL? It started when we were building apps for Ben Woldering, and this is the app that we're working on right now. It's called the Ben Compare app. And you can use it to store all your contracts and subscriptions to all the services or like your mobile phone provider or stuff like that. You can put that in the app, and that helps you, for example, get a reminder when your contract is about to expire or will be renewed or whatever. And if you are using it for your energy contract, for example, you can immediately from the app decide to click through and get a new deal, which can save you a lot of money in the end. So we're starting to build this app, and we were thinking, okay, we have all these downsides of REST, and we want to prevent a tight coupling between the app and the backend. So we decided to go with GraphQL, and that helped us a lot in also evolving our API. So we ended up building a lot more over time, right? So in REST, you can also just add an endpoint, but it's hard to add like data fields to a certain endpoint because maybe your clients do not expect those data entries in your result. And finally, because it was fun to try out something new and to see if it's production ready. So that was what we used. In terms of tools, so we use Django on the server, and that helps us building the models and all the logic behind that. It also helps us with any web-facing HTML pages. And in the end, it's also possible to do GraphQL with this. And for that, you need a Graphene Django, and Relay. And that helps you build your schema to publish to your API. On the client, there is Apollo. Apollo is very useful because it has all these different versions for all the front-end applications that you can build. For example, there are React and React Native clients. I think they even have a Vue.js client, native iOS and native Android clients, if that's your thing. So there's a whole slew of things that you can install from Apollo, and that helps to have a consistent way of working with the API. If you're building an API, it's really helpful to just query your API on the desktop, and there are also a couple of tools you can use for that. So in Graphene Django, GraphQL is supplied as well. This is very simple because you have a way to write your query over here, and then the result will get displayed on the right. And you can immediately see also here that there's documentation provided. So we have two queries in this instance. It's the me query and a node query, and we will explain what those are in a bit. But this helps with getting to know what is present in your API. And you can query what kind of types all these endpoints provide. And I like to use this one on the desktop, which is GraphQL Playground. It's a little bit nicer, and it also helps you with specifying the HTTP headers that you want to send, which is very useful if you do APIs for which you need authentication or a client ID or whatever. Also GraphQL Playground has like a built-in documentation browser, and it also has a schema. And you can see here, I hope it's legible for everyone, that there's a schema that has queries and mutations. There's a type that's address, and that implements a node interface. And then you have basic strings and IDs, and you have date times and stuff like that. So this is what we use to query our API to see if everything is working and so on. And if you know which query you want to use, then you can reuse that in your app logic. So that is the basic premise of API and the ecosystem in which we are going to build it. And this is the overview of the rest of our talk. We're going to talk about a bit of implementation. How do you use it on the server? And Niek will discuss about that. It will discuss those IDs that you just saw. A little bit about me versus user objects. Why do you need to distinguish those? A little bit about caching and fetching related entities. And then I will talk about authorization, uploading files, how to kill a server. That's very interesting. And about fragments. And at the end, we'll get to maybe reasons to stay with REST. So I will give the floor to Niek.
Thank you, Jean-Paul. So first of all, we talk a little bit about our Django application. We're specifying a very simple model, which is basically an address book with contacts, and each contact has one or more addresses. For the fun of it, we've also added a photo field, so you can take a picture of a person or an address for example, looking something up just a little bit quicker in your application. We describe the Django model also in our schema, in our GraphQL schema. Usually, GraphQL objects in the Graphene framework are called object types. Object types have to be filled in manually, so you have to specify each attribute. That's why we use a Django object type, which fixes a lot of things for us. You see here that there is a meta class, just like in Django, and it specifies an interface. For example, the relay node interface. The node interface is used to look up random items based on their IDs. This will be covered in the next slide. First, we're going to talk about that sometimes you want to add functionality to the data you're exposing. In this case, it's a photo URL. You can pass an ID to the endpoint or to the client, but more often than not, you just want an absolute URL so you don't get any discussion like where do I get the data from, which URL is it, et cetera, et cetera. There's also very convenient when you want to introduce change in your endpoints when you're moving around a bit with the content delivery networks and such. Finally, there is also the getNode function in this object type, which means anything which is called contact. When an ID is passed in for getting a random object, and it is determined to be a contact, it will use that function, which allows it to be limited to just the user's data. The IDs we'll get into in a short while, so keep that in mind. Next, on the left is a very basic GraphQL query, which is just very much like a RESTful me query. So it's my data, get the contacts of the contact, get the ID and the first name. The response is encapsulated in a small data dictionary item. This is needed because there might also be an errors dictionary item, so you need to encapsulate that a little bit. Other than that, it's quite straightforward. You see what you're querying, you know what you're getting, and when you know the schema just a little bit, you know exactly which data types will be returned. There are also mutations, because getting information is fun, but changing it is a lot more fun. You see here the create contact, which is sort of structured like a function, and it also accepts parameters very much like a function. In this case, the variables have been inlined, but you can split the variable logic from the function logic, so to speak. At the end, you get, again, the data with the mutation name returned in it, and all the contact information which has just been modified. In some cases, you don't just want to return the thing you've changed, but also the broader scope. For example, if you've changed an address, you might actually want to query out all the addresses. That is possible within GraphQL. Then the IDs. I just spoke about relay and nodes and IDs, but what are they? An ID is a complex string, but also just a string. The intelligence about the ID is kept completely at the server. So if you would like to query just a random node ID, you just throw it in the node query endpoint, and it will return to you a random object. And this seems very random, but the IDs are actually quite clever in the fact that they contain the name of the type that they are in reality. This is done in base 64. So you can just decode it on the terminal and see, oh, it's that and that information. Of course, you could say this is a security risk, et cetera, but REST does exactly the same thing. But in this case, you also have the freedom to override the implementation of the ID and actually use encryption or whatever you want. There is also the type name attribute, which just tells you what type of object it is. And the 3 dots means, well, if you encounter this type, in this case contact, then you use these fields. So you could also put in other data types and get different data based on which type it is, which makes it a very flexible endpoint, which is also, keep that in mind when designing for security. Then, me versus user. So in some applications, you might encounter the situation in which one user talks to another. In GraphQL, you might want to use the same model for this. But you'd have to implement quite some constraints in what they can and cannot do. For example, I can query someone else's information, but I'll get a lot less information than if I were to query my own data. So you could do a whole system around this. We just tried to use a Django proxy model just so to differentiate between the two, a regular user and who you are yourself. This makes it a lot easier. When returning data, you can just return the user in the function which is supposed to return data, and Graphene will wrap the appropriate class around it which takes care of your security. For this, you could use a Django object type, but it does not go very well with the proxy models. It has a bit of difficulty with it. So we inherited from the standard Django object type, which is provided by Graphene Django, and pretty much told it, ignore the further resolution when you encounter a proxy model. So otherwise, it would try to grab the user rather than the proxied user, which is a current user or whatever you want to make it. Let's see. Then there's also the caching. Caching is a bit difficult within Graphene itself. It's not that lenient towards caching, because a lot of the Django object types don't like to be cached. You would have to leverage the Django itself to implement caching, and if you do a few exotic things there, you might not be able to cache it. One way to solve this would be to not use Django object type, but just the regular object type, and have to sort of serialize it into dictionaries and lists itself. Type conversion will still work with scalars and such. It's just JSON serialized at the end, but you could cache the more primitive objects. So it's a bit difficult still, but it's only fair to also note the downsides rather than just the upsides. One strategy which is very useful if you want to cache is to just prefetch a lot of things, which is also good for performance. More on that later on, which is now. Sometimes you will have a lot of data which is queried at the same time. For example, sometimes you just want to get the contact, sometimes you want the addresses, sometimes you want contacts with addresses. And this is where both the upsides and the downsides of REST versus GraphQL get illustrated. If you just want contacts, then you can query just the contacts. If you want addresses, you could set up a new endpoint in REST, or you could use GraphQL. And with a bit of cleverness, which is the small code block on the right, you can actually look ahead into which fields will be queried in underlying objects. So if you know you're going to need to resolve contacts, you can look down one layer and see, oh, you're also going to query the addresses. We can prefetch those and limit our n+1 queries to just the bare minimum. If you want to make this a very intelligent system, you will have to go into the more nitty-gritty details of GraphQL and look into the abstract syntax tree, which are the building blocks of the parser, which actually parses the initial query. It's a bit nitty-gritty, as I said, but it's very much doable. And now I'm going to hand over to Jean-Paul.
Thanks, Niek. Niek talked a little bit about the implementation on the server side. So let's talk a little bit about how you use GraphQL. Of course, you need to have some authorization mechanism. And in this case, we just use OAuth 2. That means that we can query certain REST endpoints to get your refresh tokens and your access tokens. And if you have those, you can easily add them, for example, to GraphQL Playground and then be logged in there. The standard OAuth 2 endpoints are RESTful, and we kept that as is because that's convenient. We can just leverage the existing tools for that. And also, a lot of clients know about OAuth and so on. So when you set the HTTP errors, something with the sound. Okay. Yeah. When you have that, you can access the me object, for example, and get all the things that belong to you. Uploading files is a little bit tricky because GraphQL is about specifying data coming in and coming out. It's not about files and so on. So we had to do a little bit around that. And the solution that we ended up with was to have a post or a put endpoint somewhere where you can send files. If you have received the uploaded file, you store it somewhere in a temporary directory or whatever. You return an ID, and you accept that ID in a GraphQL call. And that looks like this. At the top, you see a little curl command line where we upload a JPEG to an upload endpoint, and we get back a little bit of JSON that says this is the node that you want to use. And in the block below that, you see the mutation that we use to change a contact. So we update a certain contact, and in this case is one of the first contacts that I entered into the system. And I want to change some details. And the details that I want to change, of course, are the photo ID. So this is the exact ID that I got back from the previous call. And if I now query this contact, then I can query the photo URL, which is what Niek explained, a little bit of logic that translates this ID into a URL that you can just present in your API, in your app. So this is what we use to upload files. In our case, there's a lot more around it because people also want encryption, and you maybe want to share files and stuff like that. But you can all add that into this. Now is maybe something that you need to think about when you're implementing a REST API, and that is people can kill your server. For example, you can do this. You can do recursion. And what this is I query a node, and in this case, it's an address. Right? So you see that I extract an address here. This is the node for an address. And I get a street and a number for that. And I can also extract all the contacts that live at that address. So that means that I can get their ID or their first name or whatever. But I can also get addresses from those contacts, which means that from an address, I can also get all the contacts that live within that address, and I can keep that up. So that means that I can create a very giant GraphQL call that just tries to overload our database server or whatever. It's nothing very fancy. This touches on one of the downsides of GraphQL. It's hard to predict the cost of a query. How do you handle this? You can prevent recursive loops. It's not always possible, but you can, for example, disallow getting a contract on an address or vice versa. Or you could add some middleware to limit the depth of a query. And in Graphene, you can plug in your own middleware as well. This is not a problem that you have in REST usually, because you can just find out the cost for a single endpoint. GitHub and others have solved this by investing in better ways to compute the query cost. GitHub uses Ruby, and well, they're not really available out of the box. And this shows a little bit what the level of maturity is for the Graphene framework for now. That aside, we can use Fragments to help us scale that server, because we can use Fragments as snippets of code that you can use to specify which fields that you want for a certain object. So here I defined a fragment that's called address, which acts on a type address. And I extract the street and a number for that for these addresses that I use these fragments on. This is very useful besides scaling servers, because you can specify these fragments in a certain area of your app. These things I always want for addresses. And you can also use them, for example, if you have these nodes queries and you know, okay, when I use a node query, I always want to have these fields on an address, and I will always want to have these fields on a contact. And you don't even need to add a type when you use a fragment, because the fragments are also typed. If you want to have other fields, of course, you do need to add the type here. So these are very useful to reuse, and we use them a lot in our app. And we can discuss about these fragments as well, because if we think that something is less convenient on the server or whatever, we can discuss these fragments or the queries that go with them, and yeah, that helps these conversations. So one last thing, maybe some reasons to stay with REST. We have to mention that GraphQL is not a silver bullet. Of course, it allows loose coupling between the front end and back end. As we discussed, it's very flexible, and it's easy to document your input and output. But it also adds a little bit of complexity to your API, because you now have to use a JSON kind of interface to communicate with your API. And it's difficult to compute the total cost of a single query, especially if you can query all these related objects, and et cetera, et cetera. As I said, we believe that the Django or Python tooling around GraphQL is still not very mature. Things that leave to be desired are caching, understanding the proxy models, et cetera. But we have a lot of fun when we use GraphQL, which is also worth something. We believe that it helps in building our app, because it's very easy to evolve our API. And in the end, we think it's very much worth it. So please give it a try if you're building your next API. And if you have any questions later on, please find us. And of course, I have to mention that we're hiring if you're interested in GraphQL or whatever. Yeah.
Okay, thank you. We have time for a couple of questions. We have time for 2 or 3 questions, so raise your hand if you'd like to ask them. Oh, that's nearby.
We are also thinking about using GraphQL, but one question I have is, who decides on the schema? Is it the front-enders, the back-enders, or together? Because indeed, the impact could be very heavy on the queries on the back-end.
Yeah.
So, yeah.
Yeah, we discuss these things together, right? And in the end, if the cost is too high for the back end, then we have to discuss this properly. It helps that our front end and back end people are very close by. They share the office, so sometimes it's like shouting across the room, and then you know the answer. Usually it goes a little bit more on, like, we're going to the drawing table, we get someone from the front end and the back end, and we decide on, it would look best if we do something like this, the schema should look like this, and then the back end is going to try out whether that is a big impact on the server. Yeah.
Have you also looked at data loaders for improving performance on your GraphQL queries?
Yeah, can you,
I've looked at it for Django, but it doesn't deal well with prefetching underlying elements, so child elements such as the address in our example. It doesn't do well with that, and it tries to do lazy loading, which makes it look like it tries to do some lazy loading, which seems like a good idea, but it still causes a lot of n+1 queries.
Any question? The last one? Going once, going twice. Thank you, Jean-Paul and Niek, for a great talk.
yeah, no problem.